How you going, guys? So the next video we're doing now here is all about finding the optimal solutions. And in order to find the optimal solutions, we need to be able to sketch the feasible region and then find out where the points are meeting. So in previous videos, we were introduced to something here called the objective function. So we've got 2x plus 3y. So remember, this here was our objective function. And the objective function, we use that to help us find out the optimal solution. Okay, so the objective function relies on the vertices that touch the feasible region. And that's what we're going to be doing in this lesson, is we're going to be sketching the feasible region. Now you have this booklet at home so you can follow on as you go along. We're going to be sketching the feasible region of this, these coordinates, of these constraints, and I'm also going to show you how to use your graphics calculator as well. So let's get to it and let's sketch these feasible regions. So let's start off. We'll start off with, turn this off here for a second. We'll write down what our feasible regions are first, our constraints. So we've got x plus y is less than or equal to 8, and x plus 2y is less than or equal to 12. So let's turn that off for a second so you can see what's going on. Okay, so in this instance, we need to find out what x and y is, what's the largest x value and the largest y value. So in this case here, we know x is going to give us 8, and y is also going to give us 8. Over here, x is equal to 12, but y is equal to 6. So we can tell that our largest x value is going to be 12, and our largest y value is going to be 8. And what this does, this helps us to sketch the boundary points for our graph. Okay? So we'll write this up here so that way we can see it. So x is equal to 12 and y is equal to 8. So that way when we start sketching this, we know what our feasible region is going to be. Okay? We also know that we're going to have certain constraints. So let's sketch this up. Okay, so obviously you'll use a ruler with this, but just for this purposes, I'm going to go Command do without it. Okay, so x, we said before, was going to be 12, so x is equal to 12, and y was equal to 8. Okay, so let's check that answer out. So x goes all the way up to 12, so we might say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We might go one more one, okay? And y goes up to 8. So 1, 2, 3, 4, 5, 6, 7, 8, and again 1 from 9. When we look at these constraints, we've got this first constraint here. And this first constraint is x plus y is less than or equal to 8. Well, we want to be able to sketch this, and we can use the x and y intercepts. So we've already done this before when we found what x and y is. Okay, so x is equal to 8, so we can put a dot here for y intercept, and x equals 8. So in this case, you get a nice straight ruler, and you'll sketch your line through. Okay. Actually, I've got a ruler, I'm going to use it. Okay. So we'll sketch our line through here so we can get as accurate as possible our solutions. Okay? So this one here was the x plus 8. Right? So the next one is x plus 2y is less than or equal to 12. Okay? So again, just like the last time, we find out what x is, find out what y is. And we found that before. So we know x is going to equal 12, so we'll put a dot here. And y will equal 6, so we'll put a dot here. Get our graphics calculator, our ruler out. We sketch it, and we've got our 2 points. Now, we want to find our feasible region. Now, we found our feasible region before, so we'll write this up here again, x plus y is less than or equal to 8, by doing something called the dot point. And that's where we dot things all over. But we really probably have to look at this point here. It's less than this line, so this line here was x plus 2y is equal to 12, And this line here was x plus y is equal to 8. Okay? So we don't write these equations up there because we don't want to be less than or greater than. Our feasible region is here. Everything below those two lines. So it's below both those lines. The next step we do here is we start identifying the vertices because we need those vertices to go with our objective function. So in this case, we've got a vertice that's here, here, and here. We don't worry about this vertice, and we don't worry about this vertice. And the reason why we don't worry about them is because they're not touching the feasible region. We're only concerned with the vertices that touch that feasible region. So in this case, let's write out those vertices. So we have something that looks like 4, 4. This one here would be 8 and 0, and this one here would be 0 and 6. So we've got the three vertices that touch this feasible region. And we're going to use those now to help us work out the objective function, with the objective function, the optimal solution. Okay. So let's take that to the next step. We'll just write out over here 0, 6, 4, 4, and 8, 0 as our vertices. So let's erase this because we need the next slide, and we'll bring it up. So the next part of the slide here is, you'll notice that we've got a table. And this table already has the objective function there that we had before. What we write over here are the vertices that touch that feasible region. So we've got 0 and 6, we have 4 and 4, and we had 8 and 0. Now, recall we wanted to find the minimum. So the minimum. So the optimal solution is what it's dictating, what it's actually trying to get us to find. We're trying to find the optimal solution which is going to give us the smallest possible answer. And we do that by using these coordinates and substituting them into the objective function. So for instance, we do the first one, it's going to be 2 times 0 plus 3 times 6, because this here is x and that's y, which then gives us a total value of 18, because 2 times 0 is going to be 0. The next one is just going to be 2 times 4 plus 3 times 4. So that gives us 8 and 12, which gives us 20. And the last one is just going to be 2 times 8 plus 3 times 0, which equals 16. So because we're trying to find the minimum, so up here again, trying to find the maximum, I was wrong. I apologise. We're trying to find the maximum, alright, not the minimum, the maximum answer. Then we choose this number here. So this here is the maximum answer of the coordinates. So we write a sentence underneath it. And the sentence has to explain how these relate to the optimal solution. So we would say something that goes on along the lines, and we'll turn this off here again so that way you can see. Okay? We would say that the maximum solution is 20. So we'll write that at the end. So is 20 when x equals 4 and y equals 4. Now obviously when we know what x equals and y equals, we would write that. So for instance, x equals, let's say, shirts and y equals shorts, we would say the maximum solution would be 20, could be profit or cost, we'll say profit, $20, when 4 shirts are sold and 4 shorts are sold. So have a go at that there. What we're going to do now is we're going to have a look at the same question with the same coordinates, okay? And we're going to put it onto a graphics calculator so we can see how we do that. So let's have a look at that. Let's have a look back at the constraints that we had beforehand. So the constraints we had was 8 plus y is less than or equal to x, and x plus 2y was less than or equal to 12. Okay, so to write that, we'll write that here. X plus 2y is less than or equal to 12. Well, what we need to do here is, before we can put it in our graphics calculator, we have to turn both of these into y equals mx plus c. Now, we did a lesson on this beforehand, how we changed the subject. So we want y to be the subject in each one, because we want them both in the form of y equals mx plus c. So in this case here, all we're going to do is just bring the x across. So change the side, change the sign, so we end up with y is less than or equal to 8 minus x. And that's it. With this one here, we've got a couple of steps we need to do. Obviously, we bring the x across again first. Okay, so change the side, change the sign. So now we get 2y is less than or equal to 12 minus x. But I still want y by itself. So what I'm going to do is I'm going to divide everything by 2. So I divide all this here by 2. I cross that out because that's going to be divided by 2. So therefore I get y is less than or equal to 12 minus x over 2. And these here are our two equations that we're going to use in our graphics calculator to sketch up the graph. So let's have a sketch of the graph, get the same, see if we get the same answers we did before. Okay. So let's bring this up. Alright, so we've got a graphics calculator up here. Okay, so if you look over here, you can see that graphics calculator we'll be working on. Okay? Let's see, should actually be able to see it. Yep. So let's work on this. So again, we're going to raise these out, but I'll put them down below here so that way we can actually see them. So we've got y is less than or equal to